Hey students, welcome back to Lakshya Education Online. मेरा नाम है क्षितिज शर्मा and this is episode number 2, chapter 1, standard 9, mathematics. In the first episode of chapter 1, we discussed about different sets of numbers. We discussed about the sets of natural number, whole numbers, integers, rational numbers and real numbers. Now in this episode, we are going to start from the NCERT textbook, chapter 1, exercise number 1.1. So let us start episode number 2. The first question of the exercise in your textbook on page number 5. It is 0 a rational number? Can you write it in the p by q form where p and q are integers and q not equal to 0? So first of all, we have to think what a rational number is. We know the definition of rational number is the number which can be written in the form of p by q. It is called a rational number. Now the question is 0 a rational number? We know that rational numbers include positive integers, negative integers, positive non-integers, negative non-integers and 0. It means 0 is included in rational numbers. So yes, answer is 0 is a rational number. Now what will be the p by q form of 0? The p by q form of 0 is, we know that there should be a numerator and a denominator. So 0 upon which number should you write in the denominator? You can write any integer in the denominator. If you write 0 upon 1, it is 0. If you write 0 upon 11, it is 0. If you write 0 upon 99, it is 0. So you can write any number in the denominator, but it must not be 0. So p by q form of 0 is written this way. Here q, that is the denominator term, is not 0. So this is the answer of this question. Now question number 2. The question is, find 6 rational numbers between 3 and 4. If you think how many numbers can be there between 3 and 4? If you think for integers, you cannot find any number between 3 and 4. But here we have to find rational numbers. Remember one thing, between any two numbers, we can have infinite number of rational numbers. It means between 3 and 4, we can have infinite numbers of rational numbers. Now how can we get 6 rational numbers between 3 and 4? The easiest way to get rational numbers between 3 and 4 is to find numbers in decimal fraction. We can write 6 numbers like 3.1, 3.2, 3.3, 3.4, 3.5 and 3.6. These are the 6 rational numbers between 3 and 4. This is the easiest way. These are decimal fractions. But there is another way to find rational numbers between given two numbers. Let us see one more method. In the second method, what we can do? First of all, we should see that is this number given in p by q form? No, it is not given in p by q form. Then first of all, we should write it in p by q form. 3 means 3 upon 1. As there is no any denominator given here, there is 1 as the denominator. So 3 by 1 is 3 and 4 can be written as 4 by 1. Now to find rational numbers between these two numbers, first of all we should check whether the denominators are same or not. If the denominators are not same, then you should make it same. But here the denominators are same. So first you should think how many numbers do we want between these two numbers? We want 6 numbers. Now the easiest way to get these 6 numbers is, as we want 6 numbers, remember 6 plus 1, that is 7. We should multiply both of these numbers by a number more than this number in numerator and denominator. So once again, as we have to get 6 numbers between these two numbers, 6 plus 1, 7, it means you should multiply both of these numbers by 7 upon 7. If you had to find 8 numbers between these two numbers, then 8 plus 1, 9. You had to multiply it by 9 upon 9. Let us see here. Here for 6 rational numbers, we will multiply both of these numbers by 7 upon 7. So we will write multiply 3 by 1 and 4 by 1 by 7 upon 7. If you multiply this, 3 upon 1 multiply by 7 upon 7. What do we get? 3 into 7, 21 upon 1 into 7, 7. We get 21 upon 7. Now what this 21 upon 7 is? This 21 upon 7 is this number itself. It means 3 by 1 is equal to 21 by 7. It means you can write at the place of 3 by 1, you can write 21 upon 7. Now for the second number, 4 by 1 multiplied by 7 by 7. 4 into 7, 28 upon 1 into 7 is 7. It means this number 4 by 1 is equal to 28 by 7. So these are the two numbers which have same denominator. Now why have we multiplied these two numbers by 7? Because we want 6 rational numbers between these two numbers. So there must be a gap of 6 numbers at least between these two numbers. Here in the numerator term there is no gap. The numerator is 3 and 4. There is no any gap in between these numbers. So to get that gap we have multiplied it by 7 upon 7. See, here the number is 21 by 7 and 28 by 7. The gap between 21 and 28 is after 21, 22, 23, 24, 25, 26 and 27. There is a gap of 6 numbers. So you can easily get 6 numbers between these two numbers. Therefore, we can write that 6 rational numbers between 21 by 7 and 28 by 7 are, the numbers will be after 21, 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. You can see here 1, 2, 3, 4, 5 and 6. These 6 numbers are the rational numbers between 21 by 7 and 28 by 7. But we already know that 21 by 7 is equal to 3 by 1 and 3 by 1 is 3 itself. And 28 by 7 is 4 by 1 and 4 by 1 is 4 itself. It means the numbers between these two numbers are same as the numbers between 3 and 4. So finally we will write that 6 rational numbers between 3 and 4 are 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. These are the 6 rational numbers between these two given numbers. Now let us see the next question. Next question is question number 3, and the question is find 5 rational numbers between 3 by 5 and 4 by 5. Here the two numbers are given in P by Q form and we have to get 5 rational numbers between these two numbers. So first of all we will check, are the denominators same? Yes, the denominators are same. Now check numerators. What is the gap between the numbers of numerators? The numerator in the first number is 3 and for the second one it is 4. The gap between 3 and 4, there is no gap. So to get that gap of 5 rational numbers, as we have to get 5 rational numbers, 5 plus 1, 6. We should multiply both of these numbers by 6 upon 6. So we will write multiply 3 by 5 and 4 by 5 by 6 upon 6. Let us multiply 3 by 5 multiply by 6 upon 6. What do we get? 3 into 6, 18 upon 5 into 6, 30. Similarly 4 by 5 multiply by 6 upon 6. 4 into 6, 24 and 5 into 6, 30. So here we got 18 by 30, which is in fact equal to the first number, that is 3 by 5, and the second one is 24 by 30, which is in fact equal to 4 by 5. Now we want 5 rational numbers between 3 by 5 and 4 by 5. It means we need to find 5 rational numbers between 18 by 30 and 24 by 30. Now let us check what is the gap between the numerator terms. After 18 up to 24, 19, 20, 21, 22, 23. 5 gaps are obtained. So therefore we can write that 5 rational numbers between 18 by 30 and 24 by 30 are, after 18, 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30, 1, 2, 3, 4, 5. 5 rational numbers between these two numbers. So finally we can say that the 5 rational numbers between 3 by 5 and 4 by 5 are 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. This is the answer of this question. Now let us take one more question. It is an extra question. This is not given in your textbook, but according to me it is an important question. By the same method, the question is find 4 rational numbers between 2 by 3 and 3 by 5. Now we want to find 4 rational numbers between these two given numbers. First of all, we check that the numbers are given in P by Q form. Check whether the denominators are same or not. First number is 2 by 3, second number is 3 by 5. Denominators are not same. So first thing, we have to make the denominators same. To make them same, 3 and 5, their LCM. LCM of 3 and 5 is 15. So we will make denominator 15 for both of the numbers. To make the denominator 15, what shall we do? We can multiply 3 by 5. So 3 into 5 will be 15, and we can multiply 5 by 3. So 5 into 3 will be 15. In that case, denominator of both the numbers will become equal. But remember one thing, whenever we multiply any number, we cannot multiply only the denominator. So we will have to multiply the numbers by the same number in numerator and denominator both. If we want to make this 15, then multiply it 5 in numerator and denominator both. So we will write multiply 2 by 3 by 5 upon 5 and 3 by 5 by 3 upon 3. So what do we get? 2 by 3 multiplied by 5 upon 5. 2 multiplied by 5, 10. 3 multiplied by 5, 15. So the first number will become 10 by 15. Now this 10 by 15 is equal to 2 by 3, as we have multiplied it by 5 upon 5. Second number, 3 by 5 multiplied by 3 by 3. So 3 into 3, 9 upon 5 into 3, 15. So we got 9 by 15. This 9 by 15 is equal to 3 by 5. So both the numbers are now transformed into the numbers which have same denominator, 15 and 15. So the numbers have same denominator. Now let us see how many gaps of numbers in between the numerator terms. The numerator terms are 10 and 9. There is no gap between these numerator terms. We want the gap of, how many numbers do we want? We want 4 numbers. So we want the gap of at least 4 numbers. So now what shall we do? We will multiply these numbers again by, as we want 4 numbers, so 4 plus 1, 5. So again we will multiply both of these numbers by 5 upon 5. Now don't get confused. The first time we multiplied them by certain numbers to make their denominators equal. And now for the second time we will multiply them to get the gap of the given number of times. So let us do it. Multiply 10 by 15 and 9 by 15 by 5 upon 5. This time 5 upon 5 with both numbers, because we want 4 rational numbers between them. So 4 plus 1, 5. Multiply by 5 upon 5. Let us see what do we get. 10 by 15 multiplied by 5 upon 5 equals to 10 into 5, 50 upon 15 into 5, 75. So the first number is 50 upon 75. Now this number 50 upon 75 is equal to 10 upon 15, and 10 upon 15 is equal to 2 by 3. It means this 50 by 75 is equal to 2 by 3. So this number and this number both are same numbers. On the other side, 9 by 15 multiplied by 5 upon 5, 9 into 5, 45, 15 into 5, 75. So the number is 45 upon 75. So here 45 upon 75 is equal to 9 by 15, and 9 by 15 is equal to 3 upon 5. So now we want 4 rational numbers between these two numbers. So finally we can say that 4 rational numbers between 50 upon 75 and 45 upon 75 are. See here, denominators are same. Numerators have how many gaps? 50 and 45. The gaps will be After 45, 46, 47, 48 and 49, gap of 4 numbers. So those numbers can be adjusted between these two numbers. So the 4 rational numbers between these two numbers are 49 upon 75, 48 upon 75, 47 upon 75, 46 upon 75. These are the 4 rational numbers between 50 upon 75 and 45 upon 75. It means finally we can say that 4 numbers between 2 by 3 and 3 by 5 are 49 upon 75, 48 upon 75, 47 upon 75 and 46 upon 75. This is the answer of this question. This way you can find any number of rational numbers between any two given numbers. Remember one thing, you should check whether the given numbers are rational, are they in p by q form, then check their denominators are same or not. Make the denominator first of all same and then check how many numbers do we have to find between them. As many numbers you want to find plus 1. So multiply both of the numbers by that number in numerator and denominator, and you can find the gap between those numbers and you can get the numbers whichever you want. Now the next is question number 4. There are some statements given and the question is we have to state whether the following statements are true or false with reason. Some of the statements are given here, like every natural number is a whole number. Is it true or false? Every integer is a whole number. Every rational number is a whole number. We have to say whether it is true or false. To get these answers, first of all, we will go back to episode 1, in which we had discussed about 4 sets N, W, Z and Q. What we had seen, we know that the set of natural numbers is a subset of the set of whole numbers. It means all the numbers from natural numbers are included in whole numbers. Similarly, W is a subset of Z, that is integers, and integers, the set is subset of rational number set. It means N is subset of W, W is subset of Z, Z is subset of Q. Now here, what the meaning it states? It says every natural number is included in set of whole numbers. So we can say that, we can show it by this kind of arrow. This number is this number. It is included in this number. Every natural number is a whole number, but its reverse is not true. Means we cannot say that every whole number is a natural number. No. Here this indicates that every natural number is a whole number, but its reverse is not true. Means every whole number is not a natural number. Similarly, every natural number is an integer, but every integer is not a natural number. Moreover, every natural number is a rational number, but every rational number is not a natural number. Now we will go from whole number to integers. We can say that this way arrow, it means every whole number is an integer, but every integer is not a whole number. Moreover, we can show this way, every whole number is a rational number, but every rational number is not a whole number. This is relation from whole number to the rest of the sets. Now from integer to rational number, the arrow can be like this. It means every integer is a rational number, but every rational number is not an integer. You have to take a screenshot of this terminology in your mind. Remember this forever. Whichever kind of question, whichever kind of statements you will see, you can get the answer very fast. So now from this we can obtain the answer of these 3 statements. The first statement is every natural number is a whole number. You can see here natural to whole, the arrow is going from natural to whole. It means every natural number is a whole number. It is true statement. So it is true. If you want to give the reason, then all the numbers which are present in natural numbers, they are included in the set of whole numbers. Therefore, every natural number is a whole number. Second, every integer is a whole number. See here, integer to whole. Integer is Z, whole is W. Integer to whole, this is reverse direction, which is not true. We can say We can say that every whole number is an integer, but every integer is a whole number. This is not true. So we can say this statement is false statement. Why? Because integer contains positive integers, negative integers and 0. But whole number contains only 0 and positive integers. They do not contain negative integers. Therefore, every integer is a whole number. That statement is false statement. Next, every rational number is a whole number. Here rational number means q and whole number is w. You can see q to w. This arrow is going left to right and the statement says q to w, which is not true statement. So every rational number is whole number. That statement is again false. Now the reason is that whole numbers contain only 0 and positive integers, whereas rational numbers contain integer as well as fractions, means non-integer also, and negative numbers also, which are not included in whole numbers. Therefore, every rational number is a whole number. That statement is false. So students, you have to remember this forever. So my dear students, these were the sums from exercise 1.21. These are very important sums, so practice well. Now this is the end of episode number 2. In the next episode, we will continue the chapter and we will do the next exercise. Till then, practice well for this exercise. If you like the videos, then give the like, subscribe the channel, share the videos with your friends and tell them to subscribe the channel. We will meet in episode number 3. Till then, keep studying online with Lakshya Education Online.